Welcome to Brain Vision.
A jet is traveling at a given speed, and we have the rate at which fuel is being spent, as well as the rate at which the engine takes in air. We also know the drag resistance and the relative speed of the air and the fuel to the plane. Now we want to calculate the acceleration of the plane at this given instant in time. So since the mass enters and exits the plane at the same time, we can combine our flow equations as follow. So the sum of the forces acting on the plane must equal to m dv dt minus the relative speed of ejection times the mass flow rate of the ejected fuel plus the relative speed of the injection times the mass flow rate of the injected air. So this is our modified flow equation. Now for this equation, we know the mass m is 7,000 kg. We know that dv dt is simply the acceleration of the plane a, and this is what we wish to calculate. v dE is equal to 12,000 meters per second. And the mass flow rate, dme dt, is equal to 0.8 plus 200, which is 200.8 kg per second. Now, we can find the velocity v in SI units. We know that v is 720 kilometers per hour, so we convert this to meters per second by multiplying it by 1,000 and dividing by 3,600. Since there are 1,000 meters in a kilometer and 3,600 seconds in an hour. And so we get the speed of the plane v to be 200 meters per second. And this is equal to the rate of injection v, the relative speed of injection v di. And finally, the mass flow rate of injected air dmi dt is equal to 200 kg per second. Now, if we look at our free body diagram, we need to know the resistance or the drag force acting on the jet. And we are given that this drag force is equal to 55 times v squared, but we've calculated v. So we can calculate this drag force as 55 times 200 meters per second squared. And so this drag force is 2.2 times 10 to the power 6 newtons. Now, if we refer back to this free body diagram, we can see the jet is moving horizontally. The vertical forces on it are balanced, its weight and the uplift force, and acting along its line of motion is the drag force alone. So if we go back to our flow equation and we take the left direction as positive, so the sum of all the forces, remember, is equal to m dv dt minus v dE dme dt plus v di dmi dt. So if we substitute our values into this equation, so the only force acting along the direction of motion is the drag force minus 2.2 times 10 to the power 6. Since it opposes motion, and we're taking left as positive, that's negative. The mass is 7,000, and we said dv dt is acceleration a. Remember, we want to find the acceleration of the plane. Minus 12,000 into 200.8 plus 200 times 200. So you can see that we simply have one unknown in this equation, which is the acceleration of the plane A. And if we rearrange, we find that this acceleration is 24.2 meters per square second.